G'day there, everybody up in northeast Victoria. It's Graham Anderson here from Agriculture Victoria. I'm just providing a climate update and looking at the long-term rainfall records for Milawa in the northeast. And this is a talk that was given at the TAFCO climate workshop at the end of May. And congrats to all the people up there involved in setting up those new weather stations. That's fantastic stuff. Okay, so here's a map of where it rained last year in 2016. That's 12-month rainfall, and this is a decile map. So basically these colours here show where rainfall was average for last year in 2016. And this colour here, this is decile 10. That's where last year's rainfall was in the equivalent of the wettest 10% of years on record. So you can see a big part of Australia had, a very wet year, including us. And we'll talk about basically what was behind that. So the Indian Ocean dipole is a key driver of variability in this part of the world, and we'll look at the effect on Milawa's rainfall in a minute. So looking at this year, we can see there was a bit of moisture around in January. This is a monthly decile for January. In February, we can see there was a bit of moisture over in Western Australia, but a bit of a drier pattern certainly to our north, but we were average. And in March, you can see all that moisture that came down from Cyclone Debbie as it worked its way down the coast. But largely, most of Victoria was about average. And April, again, a bit drier up north, but we were pretty lucky. We got some great moisture, tropical moisture came in and gave us some good rain. Just covered some of your part of the world, but certainly the western half of Victoria got that great rain thanks to the tropics. And just up to the 25th of May, you can just see a bit of rain there across the state. There's a sort of part in the west, which again has been wetter, more than 25 mil, and up here as well, 25 to 50 mil. Now here's a nice long-term record from Milawa. So here's 1903, it starts here, that's the first year, and you can see the rainfall goes up and down. This is millimetres up the side. This line here is just the long-term average, which turns out to be at the moment 654 millimetres. That's the long-term average. But you can see some years there's almost 1,000 millimetres of rainfall in that history, and also there's some years where it barely cracks 400 mil. So quite a lot of variability in that record, and we'll talk about what sits behind that variability. I guess you can see some pretty dry runs there, the Federation drought and World War II drought, and also the Millennium drought. And it's also worth just looking, in the last 20 years we've had 13 drier than average and 7 wetter. So, a bit of a drier pattern there, but you can see last year's wetter year in there. And it's interesting when you look at this long-term record, ask yourself, how often does average happen? Average rainfall doesn't happen a lot. It probably happens, once or twice every 10 years. So one of the key things, and this is where seasonal forecasting comes in, is there any of those years which there's some predictability about whether we're going to be above the line or below the line. And here we've got that Milawa rainfall record, but this time it's looking at the seasons. So right in back to 1903, that's the summer rainfall record. Plenty of variability there. Autumn rainfall, you can see probably a lack of the really wet autumns, perhaps in the last 20 years. Winter, that long-term winter record again, probably more drier winters there in the last 20 than wetter. And then spring pretty variable, and you can see last year's spring was pretty good. Last year's winter and spring were both pretty good. So what's behind those wetter and dry years? Well, this is a great sort of map of the key drivers of what makes rainfall in this part of the world. Now there's two key things we need to make rainfall. First of all, we need moisture in the air. You can't make rain out of dry air. And one of the key things that brings the moisture is really all of the tropical moisture that's fed in from the warm oceans to our north. So we've got the El Nino Southern Oscillation up here. It's normally got trade winds blowing towards Australia, bringing lots of moisture that feeds into our weather patterns. And then the Indian Ocean dipole is the other key driver that some years, like last year, sends a lot more moisture into the system, and that just increases the chance of, per rain event, we just get more rain when they're firing up with more rainfall. And some years they can be really helpful, like 2010 and also last year, where there's moisture coming in from both places. Whereas in, say, the 2006 drought, there was an El Nino out here, so no moisture coming in from this direction, and also the IOD was in its dry phase at the same time. So they're both really important drivers in terms of rainfall in this part of the world. But that moisture then needs to hit some cold air to make it fall out, and that's where we have you can see all of these cold fronts queued up in the Southern Ocean, and that's part of what's called the Southern Annular Mode, and those fronts flick their tails across. So it's really where that moist air meets this regular passing of cold air that makes Victoria's rainfall and your district's rainfall so reliable. So really, seasonal conditions is just about is any of these drivers doing something a bit different from one year to the next. And one of the things seasonal forecasters look at is sea surface temperature maps. Now, if you look along the equator here, the seas are a lot warmer than they are down here. But what this is, it's an anomaly map. So it's measuring areas of sea surface temperature that might be, say, 2 degrees warmer than long-term average. That's what this colour is down here. And this bluer colour is where an area of sea surface temperature is cooler than long-term average. So you can see here, this is going back to September 2006, so in the heart of the Millennium Drought. This is a really dry year. You can see an El Nino out in the Pacific, lots of extra warm water out there. Where the warmest water is where most of the extra evaporation and cloud will form, so there'll be floods and everything over here in South America. And you'll notice that this important area for where moisture should be coming into our weather patterns, all of these cooler oceans, cooler than normal, means that there's less moisture and less cloud happening in our part of the world, and so that's sort of pretty typical of a dry sort of a sea surface temperature pattern, especially for our winter and spring periods. So there's quite a correlation what these oceans up here are up to for what happens down here at Milawa. Now, if you have a look at this area of ocean to the north of Australia, and we'll see what that sea surface temperature pattern looks like when we go to, say, a wet spring of 2010. Rightio, there you can see a bit of a difference. Hopefully you can see all of this ocean in the spring of 2010, really warm, heaps of cloud, extra cloud and moisture, and big wet seasons, but also lots of extra moisture that feeds into our weather patterns down south. So you can see out there the big La Nina. The trade winds would have been stronger in those sort of years, sending more moisture. In El Nino years, the trade winds sort of break away, or if anything, even head backwards. So that's all important. And the Indian Ocean dipole, you can see here all of this water really warm, and feeding in lots of moisture for those northwest cloud bands. And just looking at that same pattern again from October 2010, that's the sea surface temperature pattern. And interesting, down here what we've got is the cloud anomaly. So these colours here are where there's a lot less cloud than normal, and these darker colours here are where there's a lot more cloud. So you can see in that wetter pattern, all of the cloud and everything was over in our part of the world, feeding in lots more moisture, and a lot less cloud out here. Have a notice, we'll have a look at that sort of the 2006 drought period and where the cloud went. Here's that dry pattern again, cooler sea surface temperatures up there in the El Nino of 2006, and you can see right over here to our north, a lot less cloud than normal, so it would have been pretty hot and dry, and there's just less moisture then feeding in, so a lot of Eastern Australia had a lot less cloud. And you can see the cloud in those situations has shifted out further east in the Pacific, or further west in the Indian Ocean. So it just means that in those years there's less moisture around our part of the world to feed into the rain-making process. And looking at last year, you can see here, this is spring last year, almost a La Nina, not quite, but the main thing was last year really warm water to our north, and also the Indian Ocean, this water over here was really quite warm, so it fed in lots of moisture. And you can see the cloud pattern there last year, heaps of cloud moisture, and really gave us plenty of that extra cloud, and that's thanks largely to that Indian Ocean dipole event. Okay, we're just having a look now. Here's those El Nino years and where it's drier, and here's where it's wetter in the La Nina years. Now, we're going to have a look at what's the impact of El Nino years at Milawa. So when we go back to that long-term rainfall record at Milawa, and we start to look at what's happened in El Nino years, there's been 28 events. And when we draw out the August-November rainfall, rather than a third of these years being dry in the decile 1 to 3 years, actually more like 3/4 of those years were dry. And so there's quite a strong signal there that, a big bias there where El Nino years are often drier. But you can see that not all El Ninos were dry because at least a quarter there were average or wetter. So El Nino doesn't guarantee dry, but it certainly increases the chance of it at Milawa. And again, when we look at La Nina, rather than a third of those years being decile 8 to 10, you can see that almost 2/3 of them are wet. There's still a third of them are average or dry, but certainly a lot less chance of a dry year in La Nina. And I guess that's one of the things about these climate drivers is they don't guarantee a wetter or dry year, but certainly it's useful to give you a bit of a heads up if they're firing up either one way. And the Indian Ocean dipole, when it's in its drier phase, a bit of less cloud and moisture drifting over this part of Australia, and you can see there it almost doubles the chance of a dry spring in that when we look at the IOD positive years or the drier IOD phases in that Milawa record. This is the effect on August to November, those sort of spring conditions. And when the IOD, like last year's in its wetter phase, you can see really quite a strong driver for Victoria's wetter years. And you can see more than half of them were decile 8 to 10. Still the odd dry one, but certainly it's worth keeping an eye on. Now we're going to talk about seasonal forecasts, and you can see here some climate models. This is the Bureau of Meteorology. They've put out their seasonal forecast for the next 3 and 6 months, but so too does the Europeans. Got their own model. We've got the American, and we've got another American model there, and also the UK MO. There's University Southern Queensland, also the Japanese. We've got APEC, which is a Korean one. But all of these models basically are looking at which parts of the world are going to be wetter and which parts are going to be drier. And one of the things that Dale Gray does with the Break newsletter, so this is, you can subscribe to this, just drop an email to the break at ecodev.vic.gov.au. But this is the current outlook using the May runs of all of these different models. So what Dale's gone, he's gone and looked at all of these models for you. Here's the European model. This is the Australian Bureau of Meteorology's forecast model. That's the Japanese. There's a couple there from the US. And these are the model runs in May, and this is June, July, August. This is sort of what they're thinking in terms of some are thinking El Nino in the Pacific, some are thinking it won't get there, and this is what they're thinking about the Indian Ocean dipole, and this is what they're thinking for Victoria. So you can see Dale looks at all of those and looks at a map of Victoria and then goes, well, the European model's got slightly dry for Victoria, so's the Bureau's model, so's the Japanese model. You can see that there's a couple of those that have got a slightly drier signal for the next 3 months. And then it also looks at the 4 to 6 month forecast for September, October, November. And looking at that at the minute for these models is 1, 2, 3, 4, 5, 6, 7, 8. So there's a few of them there that have got a slightly drier signal about them. So, and I guess, if we were doing that this time last year, there was probably just as many that had a wetter signal. So one of the things is this table just sort of has a quick heads up about what are all the global models saying about the forecast. So looking at that, I'd say there's an accelerated chance of some drier conditions popping up this year. So here's the current sea surface temperature map. You can see there's been an El Nino, a lot of discussion about an El Nino forming out here, but it hasn't quite got there, and the models are pretty mixed. Less and less of them each month are thinking that will fire up. And one of the things we'll be watching really is about what happens with sea surface temperatures and cloud patterns out here in the coming months. Probably also the Indian Ocean dipole, a bit of discussion about is that going to be in neutral, or will this area go cooler? So that's what we're staying tuned for in the coming months. And one of the things that the forecasters will be watching out is what do those sea surface temperatures do to this area north of Australia? Will the trade winds still keep blowing our way, or will they be disrupted? At the moment, they're fine. Will the cloud pattern shift, or will we still have sort of pretty average conditions? And also the SOI is the Southern Oscillation Index, and that just measures the pressure difference between Darwin and Tahiti. So if we look for the SOI, if it starts dropping in winter and spring, that just means there's a higher pressure set up over Australian region and lower pressure in Tahiti. So they're the things that tend to be watching for when they're either predicting El Ninos or seeing if they're happening. At the moment, we haven't really got any of these things. While the sea surface temperature is warm, it's not warm enough for El Nino thresholds, and most of these haven't really fired up in El Nino direction. Probably a bit of a question this year just about what that Indian Ocean dipole does. It's certainly not in the same position as it was last year, where it was sending us heaps of extra moisture. Okay, so all I've spoken about there is what's been behind our long-term variability, and those core climate drivers will be behind our future variability as well. But also, is there anything happening now that perhaps isn't part of natural variability? So one thing that is a bit different is we look at the long-term temperature record for Victoria. This is going back from since 1910. You can see the summer temperature, autumn, winter and spring. That temperature is quite variable, but certainly in the last decade or two it's been a lot warmer. And basically the Bureau explaining that we're going through a process of squeezing in an extra month of summer. So you can see warmer summers there, variability, you can see warmer, milder autumns like we've been having this year. Winter tend to be milder, not always, but you can see there's only a couple there in the last 20 that have been cooler than the long-term average. Often that provides extra better grazing conditions and pastures like that. But spring's really interesting when you look at the long-term records there. We've had, a bunch of springs in the last 10 years have been between 1, 2 and even up to 3 degrees warmer than the long-term average. So that's often even summer coming a month earlier. And so that's sort of a key part of what's part of modern day variability. And here we can just see that this is spring maximum temperatures at Rutherglen. And you can just see there's that really bunch of warm springs there that have appeared in the last 10 years. One of the other things that's a bit different, if you look at since 1950, these areas here is where the winter pressure has been higher. And basically, so the pressure over southern Australia is not the same as it used to be, it's actually a bit stronger. And you can see here, this area over southern Australia, this is the pressure graph since 1950 through to 2015. You can see it varies, and often those El Nino years are when there's higher pressure over us, but you can see there's quite a trend there that as things have been getting warmer, the actual pressure pattern over southern Australia has been getting stronger. And that's what's been happening, but it's also what's expected to keep happening as a part of global warming. And one of those things too, while we've been getting some warmer spring days in terms of maximum temperatures, when we have especially years with less cloud cover, we can still get some quite significant frosts. And so some areas in southern Australia have been experiencing still quite high frost risk. So that can be a bit of a challenge because warmer day temperatures tends to mean our plants want to have bud burst or flower earlier. But if they've still got that same frost risk window, that can be a bit of a challenge. Now I really like this map. It's a great map. It was put together by some work by AgVic in Western Australia. David Stevens. He was looking at basically rainfall seasonality and how it's changed since the year 2000 compared to the last 100 years. And you can see here's a map of summer dominant uniform rainfall throughout the year, or whether it's winter dominant or strongly winter dominant. And basically saying that the rainfall in the last 15 years, but those zones basically have shifted south, and you can sort of see that what was the uniform rainfall zone has sort of shifted now into the parts of northern Victoria, which used to be all pretty well winter dominant. So that's largely is what the climate models expect, and that's what's been happening, and I expect that'll continue in future. One of the things to note, though, from a farming point of view, is that profitable agriculture is happening in every climate zone. So it's not the climate zone that determines whether farm businesses are profitable, but there are some challenges when you're used to operating in a certain sort of variability, and that starts to change a bit. So that's part of the challenge of what we're wrestling with in getting better at managing seasonal risk. And these are all of the things that farmers are doing to better manage seasonal risk. We've got a lot of things in our favour, a lot of new technologies R&D, genetics and innovations which we're applying now, and there's plenty more coming on stream. I guess improved on-farm and regional infrastructure. So when you think about things like fodder or water storage, communications, transport, there's a lot of really good things that help us manage climate risk. Also, this growth in local and export markets, and also the biosecurity, keeping things clean so we can keep those export markets open. That's been really important because basically the more money we bring in from export markets, the more money we've got to actually spend on things like better infrastructure or on-farm water storage or whatever. One thing that's been really critical is good business management for variable years and income. It seems these days in farming, when everything goes right, you can make more money than ever, but also within a fairly short time, things can go wrong and you got a bad season, and if the markets are low, you can probably lose more money than ever. So this ability to manage for variable years and income is becoming more and more important. Also, good farm planning, looking after soils and pasture, maintaining good cover has been really important, because often a lot of the damage is done in those years where it's either really wet or really dry. So farmers are doing a much better job at that. And a key thing, which is all around having good networks and knowledge challenge, so you've got lots of information and people to talk to around you for how we deal with any challenges that get thrown our way. So here's a few tools and links that might be of interest. Now, one tool that's being used is increasingly a bit more is deep soil moisture probes. Dale Boyd, if you're after a newsletter he puts out, there's a few deep soil probes around Victoria where they measure from 30 centimetres to 1 metre deep, just seeing how much moisture is still in the soil profile. And these soil probes, there's one here at Yuanmite. You can see from winter 2015 we had pretty dry period there, and then this is just measuring the summed amount of moisture that's in that soil profile. And you can see here it was after we got to May last year where the profile started to fill, and then it was pretty well full, and it has been ever since. So that's pretty important part of seasonal conditions, is knowing how much rain's already in the tank, and very different situation here to what it was back here. And just this is the same soil probe, but it's got the probe has measurements at various depths, and you can say here, say the black line is moisture at the 80 centimetre depth. So you can see here that the 80 centimetre level moisture didn't really get there until June last year. So while you can have rain and everything looking good on the top, these probes can sometimes tell you how far down the profile has that moisture gone, and certainly the further it's gone, the more rain in the bank you've got for dealing with the spring. There's also another good tool here. This is with the Bureau's got that on their website at the moment, and it looks at how much moisture is in the profile compared to long-term average, and that's the current state. Most of the west of the state is a bit wetter than average, or part of the world's average, and there's a bit of there in Gippsland that's a bit drier than normal. So here's a few useful links. There's the BOM chart viewer up here. That's a useful one where you can just hit play and it shows the weather charts for the next week and how the models think things are going to pan out. There's also the BOM water and land. You can get the next 4-day or 7-day rainfall outlook on the maps there. There's the BOM MEDI, which some farmers really like using too, which gives you wind and your forecasts. Climates are useful up if you're trying to make sense of your local long-term rainfall records. You can download long-term rainfall records there and interrogate that. There's Oz Forecast, Australian Weather News, and YRKnow, which is a European model. Each of those basically enable you some second opinions where, get the BOM forecast first, but then sometimes if you're trying to check about the reliability of a big rainfall event, looking at some of these other sites can give you a second opinion. And also in terms of longer term weather, next 3 to 6 months, well, we recommend the Break newsletter that Dale Gray puts out. That's pretty handy. The Bureau has these great climate outlooks every month as well, and the BOM ENSO wrap. They also have seasonal streamflow forecasts as well as the soil moisture stuff. So good luck. Make sure you use those local weather stations you've got up there, and if any more queries, don't hesitate to give us a call, and if you want to get those monthly updates, drop an email to the Break. Okay, all the best.